Hi, I'm Nicolas Pita, a PhD student from the ModelFLOWs group and a contributor of the ModelFLOWs app. In this video, I'm going to introduce you to the HODMD algorithm, a tool that can be used for pattern detection inside the model decomposition module. But first, I wanted to encourage you on using this application and more specifically the HODMD tool, showing you the article we recently published where we applied this HODMD algorithm to a UrbanFlow database. In this study, we identified two different mechanisms, one that generates the flow patterns present in the urban flows, and the other one that destroys them. Briefly, I wanted also to introduce you to the methodology of this algorithm, where we apply a sliding window to obtain the DMD modes, which are associated to an amplitude A, can decay, grow, or stay the same in time, depending on its growth rate, delta, and also can oscillate in time depending on the frequency omega. On the left, you can see a book where you can find a more deeply explained methodology of this algorithm, or you can also go to our videos to our video that is more centered on the mathematics of the different algorithms that we explain. But well, going back to the urban flow problem, here you can see on the left the domain we use for the numerical simulations to obtain this database. As you can see, it's a simplified urban flow, urban environment, where we have a flow past two mounted obstacles that are aligned with the flow direction. Applying numerical simulation to this domain, we obtain the snapshot tensor that is organized, as you can see on the right, where we have first the variables, then the 3D mesh, and finally the temporal dimension, where we collect the different snapshots from the numerical simulation. For a specific case, and you can see here some of the values for these components of the tensor, and grouping it together, the variables with the 3D mesh, we obtain the spatial dimension, and on the other hand, we have the temporal dimension that fits with the snapshot number. And well, for the HODMD to act correctly and obtain good results, we need some previous calibration. And here you have some typical values for the different parameters we need to introduce to the algorithm. On the one hand, we have the SVT tolerance that fix where we fix the singular values we retain. Then the DMD tolerance, where we fix the minimum amplitude for the DMD modes. And finally, the number of windows we use on the sliding window process. That has to be between 10 and 50% of the total snapshots. And well, if we select some specific values for these parameters, we can obtain this clear spectrum, as you can see here on the right plot, where we plot these different DMD modes regarding its frequency. And well, going back and showing you a little bit more deep the results we obtain applying HODMD to the urban flow database, we can obtain this clean spectrum as I showed you earlier. And on the right, you can see the typical flow structures we see in a urban flow environment. The most important one is the R vortex that is painted in pink streamlines. So when applying HODMD to this database, we identify two different type of modes related to different mechanisms. First of all, we have the A modes that are related to the generation of these R vortex and these flow patterns. And on the left, you can see the different mechanisms associated to the different velocity components that envelope and induce to the flow to go inside these vortices. Then we also identified other type of modes like the breaker modes, where they are the responsible of destroying these main patterns and creating the turbulent wake. You can also see on the left the different mechanisms that use for its velocity components. If you want more information or learn more about this problem, you can go to the link here and see more deeply this problem and these results. And well, that's all. Thanks for watching. And if you have any question or do you want to know more about our group or our app, you can visit us on this web. Thank you. Bye.